changes in relation to another. In some relationships, the rate of change between any two quantities is the same. These relationships have a constant rate of change. So for this first problem, it says we have a computer program. They charge customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. So when I look at this, this is the line of codes, and that is always your x, whatever comes first, and then the cost is dependent upon that, so it's our y. So when I go through, how did I get from 50 to 100? I added 50. To get from 100 to 150, I added 50. And to get 150 to 200, I added 50. Now down at the bottom, to get from 1,000 to 2,000, I added 1,000, and so on for all of them. Now, whenever we are dealing with a constant rate of change, it is always written as our change in y over our change in x. Now, when we look at this, you say, what does that triangle represent? The triangle represents the change, the word change. So this is saying the change in x, this is supposed to say x. And this is our change in y. That looks crazy. So if we look, our change in x was 50, and our change in y was 1,000. So when I actually go through and I solve this, this line right here means divide, and if I do 1,000 divided by 50, I get 20. So they are charging $20 per line. And this is the same thing over here. This is talking about the change in money. And then the bottom part is talking about the change in the number of lines we write. And this $20 represents that one line of code will cost $20, and that is called the constant rate of change. And there's also, you can also refer to this as the unit rate. So the constant rate of change is also referred to as the unit rate. It's figuring out how much did it cost for one line of code. Same thing over here. This is talking about a booster club making money for a car or for a fundraiser. And we look down here. We always label first, so whatever comes first is our x, so the number of cars, and the money is dependent upon the number of cars. And they've already done it for us, so we look and we say, we made, for 5 cars, we made $40. For 10 cars, we made $80. For 15 cars, we got $120. And for 20 cars, we got $160. So I'm trying to figure out, well, how much does it cost if I want to get my car washed, and I only have one car? So we're going to put our change in y, which was 40, over our change in x, which was 5. And when we divide 40 by 5, we get 8. So we know that this is talking about that's $8 per car washed. Per All right, now when I look at this, it's the exact same thing. They said $40 is a change in money and change in cars, and they simplified it to say $8 is 1, and this is also referred to as the unit rate. Now another trick is saying, what is 40 divided by 5? It's 8. 80 divided by 10 is 8. 120 divided by 15 is 8. And 160 divided by 20 is also 8. Looking at this one, we're going to go through this, we'll go through the second one actually. This one is very similar. Basically, we have to find the change. Oh, I forgot to label. This is our x, and this is our y. To get from 2 to 3, we added 1. To get from 3 to 4, we added 1. To get from 4 to 5, we added 1. On the bottom, I don't know how you get from 144 to 216, so I'm going to subtract the 2. And when I do that, I find out that that's a 2, sorry, 72. So I'm adding 72 on the bottom. And just to make sure, I'm going to do 216 plus 72 to see if I get the next number, which I do. So I know that I'm adding 72 on the bottom. So now I always put my change in y over my change in x. And my change in y was 72. And my change in x was 1. So 72 divided by 1 is just 72. So I discovered that there is going to be 72 students per bus. fill it in. All right, and the other one, if you wanted to solve it, you can check your answer. It would have been 9.6 repeating. Minutes, miles per minute. All right, this next one, so now we're looking at it with a graph. What I like to do is I don't always like to use the equation. What I like to do is I like to make a table. So what I like to do is I like to say, okay, this is a car driving at a constant rate. I'm going to make a table just like we looked at earlier. When I look at this, my x, if I look, it was 0, and my y was also 0. So that means at 0 miles, at 0 hours, I traveled 0 miles. The next one, I have 1. If I travel for 1 hour, I go 60 miles. The next one, if I go 2 hours, I'm traveling 120 miles, and in 3 hours, I traveled 180 miles. So just like we did before, you can find the change. You're adding 60, we're adding 60, we're adding 60. Over here, I'm adding 1 all the way down. And when I look at this over here, I'm going to put my change in y, which was 60, on top of my change in x, which was 1. And I get that they are traveling 60 miles per hour, which is exactly what they did up here as well. I'm going to show you all a trick as well. So whenever you see the number 1 right here, that is saying that in 1 hour it's 60, you travel 60 miles. Whenever you see that the x represents 1, then the y is actually your constant rate of change. So our constant rate of change was 60, which we already discovered. So if I look, 0, 0 represents in 0 hours you travel 0 miles, and 160 represents 60 miles in 1 hour. That's how far we traveled. So when I look at this one, I don't actually have to make a table because I see that this is 1. So I would say their constant rate of change is 30. So they are traveling 30 miles in 1 hour. So you can write 30 miles per hour. And the 0 represents 0 miles in 0 hours. And 130 represents 30 miles in 1 hour. So we traveled 30 miles in 1 hour. So now looking at this, it's trying to compare the two. So we look at this and we say, oh, okay, pedal rentals, they're trying to say who's better. So I look at both of them and I say, well, how much is 1 hour? So I need to figure out which one of these is better by finding the constant rate of change. This one, they've already done the math for us, basically. So I say my change in y was 12, so that goes on top. My change in x was 1, so 12 divided by 1 gives me that they are charging $12 per hour. Now over here, I need to figure out their points. I know that this, my x is 0 and my y is 0. Over here, my x looks like it's at 1 and my y is at 8. And right here, it looks like my x is at 2 and my y is at 16. Now, do I have to do any work? No, I could make the table with my x and my y and say that 0, 0, 1, 8, 2, 16. It's not letting me write it. That's supposed to be a 16. And then you find the change over here is that you're adding 8 every time, and over here you're adding 1. So it'd be 8 over 1. Or I can say, hey, I see a 1, so I know that they are charging $8 per hour. So actually the better choice would be the pedal rentals because they are cheaper. And that's where I'm going to stop.